API or Application Programming Interface. What does this mean? Where we find it? How to use it? And more about API you can learn in this video. It's for very beginners, who doesn't have any idea about API. If the topic is interesting for you, then you have to watch this video through to the end. At the end you will understand API, how to use it and why API is very important for you as developer. APIs are everywhere, and most of us have to deal with them on a daily basis, without even realizing it. Every time we post an update on Facebook, compare flight prices on a travel website, or do an online banking transaction on our smartphone, there are APIs behind it. In fact, most of us use hundreds, if not thousands of APIs every day. But what is API exactly? API is an interface for data exchange. This means, API is to transfer data from system to another, or between server and client, etc. It enables two unknown systems to communicate with each other. It provides standard commands for developers, to perform common operations, so that code does not have to be written from scratch. This means for you as a developer, that you don't need to implement every function by yourself. You can use already existing functions from other systems in your system. To make it easier to understand, let's see this example. Assume you want to write a code in C#, and you need to convert a string to datetime. To do this you have two options. Either you write a code to convert this string to datetime format, or you can use the function, toDateTime. Of course using the function is easier than implementing it. This function is an API which is provided by a library. So using the function means, you are using an API from a library, but this was only an example and doesn't mean that we use API only in the programming languages. Let's take another example from your day. Let's say you're hungry and want to prepare a cheeseburger at home. This consists of the following parts: bread, meat, cheese, and salad. To prepare the burger, you need to have these 4 parts. How to get these parts? You have two options: either you make everything yourself. This means that you bake the bread yourself at home, prepare the meat with the spices and so on. The second option is to go shopping and buy each part from the supermarket, which is also available there. If something is not available there, then you need to make it yourself. Let's compare the two options. Making everything yourself will cost time and effort. The result could not be satisfied if you are not good in baking the bread or preparing the meat or something else. The second option is more interesting and easier, because you don't have to do everything, which is available in the market. Of course you can also order the burger at the restaurant, but we are now talking about preparing it yourself. So I think you will also choose the second option to prepare the burger at home, after buying the different parts from the supermarket. The supermarket in this example is a software or a source. Your program or software is to prepare a cheeseburger. Your needs are available in another source, in the supermarket. You chose to buy the parts, not to make them by yourself. The supermarket offers these parts as API. You can get each API you want. You can get all APIs from one supermarket or from different supermarkets. It depends on where you can find them and which one is the best for your needs. So you get the APIs from another sources and use them in your program of preparing the burger. But to get an API you need to do some steps. In this example are the APIs in a supermarket. The supermarket needs to know what you want to buy, and also want the money. Nothing in the supermarket is free. You need to pay. So you tell the supermarket that you want to buy bread, for example, and you give him the money. You will get the bread from the supermarket. Your process of giving the needs name and the money is called request. The process of the source or the supermarket is called response. You ask for something and give some information. The source answers the question with some information. So for each request there is a response. Also if the source doesn't have your need, he tells you that your need is not available there. For example, there is no bread anymore in the supermarket. You will get the response that no bread is available in the supermarket. The burger is the same as a client. The supermarket is like a server. Client sends requests to the server. The server receives these requests, processes them, and sends back a response. This is how the client-server model works. Let's take a simple example to understand how the web works. I have my computer here. I have an internet browser on it. This browser is the web client. I will use the browser to connect to a server. This works on the basis of an address that you enter in the browser. The address is called a URL, or Uniform Resource Locator. First let's understand what is the difference between URL, URN and URI. URL stands for Uniform Resource Locator. Here you search for something by address. For example, the link for Google homepage. URN stands for Uniform Resource Name. Here you search for something by name. For example, searching for a book by its ISBN number. URI is the superset term for both URL and URN. This means every URL is a URI, and every URN is a URI. URI stands for Uniform Resource Identifier. Let's come back to our example. I want to go to the Google homepage. I enter the URI in the browser. The URI consists of different parts. The first part is HTTP. This stands for Hypertext Transfer Protocol. What does that mean exactly? We will understand it in a moment. The main thing is to understand that it is a protocol. There are different protocols that can be used here, such as HTTP, HTTPS, FTP, etc. Let's focus on HTTP. This protocol regulates how the page is transmitted from the server to the client. So the user has entered an URI into the browser. The browser converts the URI into HTTP request. This request consists of two parts, headers and body. What is in headers and what is in body? I will explain this to you in detail later. First, I will finish discussing this example. The headers always consists of two parts, URI and a verb. URI in our example is the link for the Google page. The verb is get. Get is a verb to read something from the server. So the HTTP request looks like this. Headers consists of URI and get. Body is empty. This request is sent to the server. That happens on the basis of the protocol. That is the task of the second T in HTTP, which stands for transfer. The server interprets the request and searches for the files. Then the server sends the status of the search and the data to the website in the form of an HTTP response. The response consists of two parts. Status and body. Status tells you what the result is. That means you can know from the status whether the request was successful or not. For example, status 200 means that everything is okay, and the request has been processed successfully. The body contains the page in the form of HTML. Hypertext Markup Language. As you can see, HTML and HTTP start with HT, which stands for hypertext. Hypertext is text that can be linked to another text. This means that you can click on a text, and you will be navigated to another page. The browser receives the response and compiles the page. That means the browser renders the page. The user gets the page displayed on his screen. In this example, you can see the Google page on the browser. Now the user can click something else again on the Google page, then a new request is created and sent to the server. The server interprets the request and sends back a response. For each request there is a response. Once the response is received, it's all done. This is how the web works. In this example I showed you how to open a page. We did it with the verb get. But what should I use if I want to delete something from the server, or if I want to update something on the server, or to do something else? There are different verbs for this. These are summarized in the acronym CRUD. CRUD stands for create, read, update, and delete. In the HTTP context, these verbs have a different name. Create is called post. Read is called get. Update is called put. Delete is also delete. These are the most used methods. Let's explain the function of each one of them. Post asks the server to create a new resource. For example, to log in into page. Get asks the server to retrieve a resource. It's like in the example, if you want to navigate to new page. Put asks the server to edit or update an existing resource. For example, if you want to add new data to the database. Delete asks the server to delete a resource. For example, to delete a row from database. As already mentioned, these are the most used methods. But we have other methods, which we can use in HTTP request. I will mention these briefly and tell you the function of each one. Head. The head method asks for a response identical to a GET request, but without the response body. This means that you will only get the status without the response body. Connect. The connect method establishes a tunnel to the server identified by the target resource. This can be used to access websites, which use HTTPS protocol. Options. The options method describes the communication options for the target resource. This method requests permitted communication options for a given URL or server. Trace. The trace method performs a message loopback test along the path to the target resource. This method provides a useful debugging mechanism. Patch. The patch method applies partial modifications to a resource. It's similar to the put method, but the put method is more general. As already mentioned, HTTP request consists of headers and body. And HTTP response consists of status and body. I showed you all HTTP methods, which can be used in the HTTP request. It is important to mention here, that not every method has to contain a body. I have a table here for all methods, where I mentioned whether the respective method contains a body or not, both an HTTP request and an HTTP response. Let's now see an example about one method of these methods. I showed you in the first example the method get. Let's now take another method, post for example. Let's say you want to log into Facebook. You go to the Facebook page. Then the login mask comes up, where you should enter your email address and password. You enter the email address and then the password. Then you click on Login. When you click on Login, an HTTP request is created. As mentioned, this consists of two parts. Headers and body. As mentioned, headers consists of two parts. The URI and a verb. The URI is the link of the page. The verb here is post, because you want to send something to the server here, namely, your login data. Your email address and password are in the body. The server receives the request, interprets it and sends back a response. The response contains your homepage after login, if your login data is correct. And also the status 200, that everything is okay. If your login data is wrong, you will get the response, that username or password is wrong. Let me summarize what we just discussed, before we move on to the next part. APIs, Application Programming Interface, are interfaces that are used for communication between systems. Web APIs are based on HTTP. Main part in HTTP is the principle of HTTP request and HTTP response. HTTP request consists of headers and body. Headers consists of endpoint and operation. Endpoint is the URI. Operation is the method we use to do something. There are 9 methods for an HTTP request: get, post, put, delete, head, options, patch, trace, connect. Body contains information to be sent from the client to the server. Body is also called as a parameter. However, it does not always have to be filled out. This means that the body of some methods can be empty, such as the get method. HTTP response consists of status and body. HTTP response status codes indicate whether a specific HTTP request has been successfully completed. Responses are grouped in 5 classes. Informational responses. These are in range of 100 to 199. For example, status 100 continue indicates that the client should continue the request or ignore the response if the request is already finished. Successful responses. These are in range of 200 to 299. For example, status 200 OK means that the request succeeded. Redirection messages. These are in range of 300 to 399. For example, status 301 moved permanently means that the URL of the requested resource has been changed permanently. The new URL is given in the response. Client error responses. These are in range of 400 to 499. For example, status 404 not found means that the server cannot find the requested resource. Server error responses. These are in range of 500 to 599. For example, status 511 network authentication required indicates that the client needs to authenticate to gain network access. Response body contains the data for the request, such as a web page in HTML form. One important thing about HTTP requests and HTTP response is that for every request there is a response. As long as the answer is there, the request is complete and the server can no longer remember anything. This behavior between the client and server is called stateless. This means that the server does not have to store the client's application state in memory or in a database. Therefore, all necessary information for the data exchange must already be included in the request. Stateless is the first requirement that must be met for an API to be called a REST API or RESTful API. REST stands for Representational State Transfer. REST API is an API that is constrained by the REST architecture and enables interactions with RESTful web services. There are 5 other requirements for a REST API. These are as follows. Uniform interface. Client-server architecture. Layered system. Cache. Code on demand. I will briefly describe these points. Uniform interface means that any REST client can call the server and access its resources in the same way. Using a URI makes this possible. Client-server architecture, here the client and server are clearly defined and separated from each other. This structure allows changes to be made to both components independently, without affecting the other component. A layered system describes the complete separation of client and server. When a client makes a request through a server endpoint URI, it doesn't need to know exactly which server is handling its request. In a layered system, there can be different servers, each with their own task, such as load balancing, caching, etc. The client is not aware of any of these actions in the background. Layering adds security to the REST API by allowing attacks to be isolated and contained within individual layers. As a result, attacks never endanger the entire architecture. Cache, REST servers can cache data. The server uses the cache control header to tell its client whether the data sent should be cached or not, and how long each response is valid. After the validity has expired, the client contacts the server again to receive an update. Version numbers are also used so the client can determine if the resource is up to date. Code on demand, this is optional and does not always have to be present. This means that the server sends a snippet of code, which the client then executes. For example, the code can be sent as JavaScript within an HTML response. These 6 requirements must be met for an API to be called as REST API. I mean only the first 5. The 6th requirement, as mentioned, is optional. You now know a lot about APIs. There's just one more thing we haven't discussed yet, and that's, what is included in the HTTP request body. This is always different depending on the API provider. To know this, you have to look at the respective API documentation. Let's take an example and understand what to put in HTTP request body. We have an API for the weather here. This is offered by OpenWeather. With this API you can get information about the weather without visiting this page. I'm here in the API documentation. As you can see, there is everything you need to use the API. We have the URL here, which should be put in HTTP request headers. It also describes what you can enter if you want to call up the temperatures, using the city name for example. Below you can see all the allowed parameters for this API, that you can or must enter. Such as, Q for the search, or app ID for the API key. Both are required. Or other parameters like, mode. This is used to set the output type. This means that here you can specify whether the output should be in HTML, XML, or JSON. These parameters are same as HTTP request body. This method is for retrieving the weather data by city name. However, one can retrieve the same data using other criteria, such as city ID. Geographic coordinates, zip code, etc. In each option there are different parameters that can be entered to retrieve the data. Let's look at another API, such as the Google Maps API. Here you can see the URL for the HTTP request first. Below that are the parameters that you can or must enter. First you see the mandatory parameters, such as the address or the API key. There are also optional parameters like the language, region, etc. Let's look at another API, like Spotify API. Here you can see the URL or endpoint again. You can also see what parameters there are, which are mandatory, such as Q, and which ones are optional, such as limit. You now also know what you can enter in the HTTP request body. That means you're ready to use APIs. In this part of the video, I will show you how to use an API in UiPath. You need to do one thing before using an API in UiPath. First you need the activity, HTTP request. If you don't have it, then you have to import it. You can do it as follows. Navigate to Manage Packages. Enter the following text, UiPath.WebAPI.Activities. Install the package. Once installed, you can find and use the activity, HTTP request. First, let me explain to you what the different parts in HTTP request wizard mean. Endpoint, here you put the URL to which you want to make the request. This is the first part of the HTTP request headers. Preview URL, a preview of the URL provided in the endpoint field, taking into account the information provided in the parameters section below. Enable SSL certificate verification, check this box to verify SSL certificates when sending a request. Verification failures will result in the request being aborted. Timeout specifies the amount of time to wait for the activity to run before an error is thrown. The default value is 6,000 milliseconds. This is equal to 6 seconds. You can edit the time to fit your needs. Client certificate, the location in which the client certificate file is stored. The full path must be provided. This is to be filled out if there is a client certificate. Request method, the request method to be used when calling the API. This is the second part of the HTTP request headers. You can choose one of the 9 methods. All 9 methods may not be present here. But the most important ones are always there, which are get, post, put, delete. Below you can find the parameters section. Here you can put the different parameters, which are called as HTTP request body. For example, you can put the API key here as parameter, if you need it for the API. As you can see, you can add one of the following 3 types: parameter, header, or URL segment. What is the difference between the 3 types? I will explain it to you later in the video using an example. In the attachments section you can add attachments, which should be added to the server. This section is only activated if you are using the methods put or post. Authentication specifies the authentication protocol to be used when calling the API. Here you can use the option none if the web server you are sending requests to does not require an authentication protocol. Response tab enables you to preview the request that you want to include in your workflow. It can be accessed by clicking the preview button in the HTTP request wizard, once you fill in all the fields and configure the request. Let's now test the OpenWeather API to check how we can use an API in UiPath. For example, I want to get the weather data in London City using the city name. Let's start implementing it in UiPath. First we need the activity, HTTP request. You can find it under App Integration, then under Web. If you don't find it, then you have to install the web package, as already mentioned in the video. After adding the activity, the wizard will be opened automatically. For info, if you close the wizard, you cannot open it again. First we need the endpoint. We can find it in the API documentation on the website. I will copy and paste it in the wizard. As you can see, the preview URL will be filled out after adding the URL. This will be always updated once you change the URL or add any URL segments. We can let these settings as they are. Let's now choose a request method. We want to read data from the server, therefore we need the method get. Now we need to add the parameters, if we have any. Let's switch to the API documentation to check if we need any parameters. As you see, we have first parameter, Q. This is a required parameter. We can use it to set the city name into the URL. So I will add it in the wizard. The value for this parameter can be entered here. If you have a text, you can put it here directly. But you can also use variables here. In my example I want to get the data for the city London, therefore I will add it here. In the type column you can choose one of the 3 options. For parameters you should select the option, get or post. I will talk about the other 2 types later. Let's switch again to the API documentation, to check if we still have required parameters. As you see, we have also one required parameter. It's the app ID. I will add it in the wizard. The value for this parameter should be the API key. To get your API key, click as follows. If you don't have an account, you have to create one to get an API key. It's for free. As you see, here is my API key. I will copy the key and paste it in the value column in UiPath. Now we have all required parameters. We can also add some optional parameters, like language. To know which values we can enter here, just click on Learn More. You will be navigated to the list of the languages. I will select English language. Let's now click on Preview to check the result. As you can see, we have the URL first. This URL has now additional text. It contains the parameters with the values. We have each parameter, we added in the wizard, with its value. This means, we have two options to create an HTTP request. Either as I did. Here you only enter the URL, and then add the parameters in the parameter section. Or you can enter the URL and also the parameters in it directly. How to set the URL with the parameters manually? Let's see it. We add first the URL. The URL should end with /, then question mark. After the question mark we can add the parameters. We add first the parameter name, then equal, then the parameter value. If we have another parameter, we set and symbol, then again the parameter name, then equal, then parameter value. And so on. We do this for each parameter we want to add. Let's take the same example, what we already created in UiPath. We have first the URL, then question mark, then the first parameter, then equal, then the value. In our example, we set the value London. After that we add and symbol, then the second parameter name with its value. I mentioned in the video that we can add one of the three following types in the parameter section. The first type is the parameter, what we already discussed. The second type is URL segment. URL segment is used to make the URL more dynamic. For example, if you want to add a variable to your URL, you can use the URL segment. How to use it? We set the segment between braces. How to use it exactly? I will show you in UiPath in a minute. And the last option in the parameter section is HTTP header. HTTP header can be used to add some information to the header, for example, cookie, content type, etc. Let's go back to UiPath to see the result. So we talked about the URL. We have also the request method we used. And then the status code. In this example, it's 200 and it means that everything is successfully executed. We have below the response body. It's in JSON format. This is the standard format for this API. We can read all information about the weather in this response. But we can also change the format using a parameter. Let's switch to the API documentation to check which options we have for the format. As you see, we can choose one of three formats, XML, HTML, or JSON. Let's add this parameter to the wizard. I will select the XML format. Make sure you write it in small letters, as it documented in the API documentation. I will click again on the button Preview to check the new result. As you can see, the response body is now in XML format. Let's now go back to the Request tab to use in URL segment. As mentioned, we can use the URL segment to make the URL more dynamic, and to replace some values with custom input. I will delete the text weather from the URL, and add an URL segment. I will add it between braces. Now click Add URL segment. Then write the same name, what you wrote in the URL. In the value you can then set the value you need. In this example it should be, weather. As you see, the preview URL is automatically updated with the URL segment. It took the value from the parameter section. Let's click again on Preview button to check the result. As you see, we have the same result again. Let's now add a new parameter, to get the temperature in a specific format. First I will add the parameter name. Then I will click on Learn More to get more infos about this parameter. I will choose the option metric, to get the temperature in Celsius. Add this into the value. Now I will click on Preview button, to see the new result. As you see, we have now the temperature in Celsius unit. We have also another information about the weather in London, like sunrise, sunset, etc. I am done with HTTP request. I will click on OK. The wizard will be closed automatically by click on OK. Now we need to create some variables to store the result. I will create a variable for the status code. It's of type integer. And also a variable for the result. It's of type string. Now the HTTP request is ready. I will add write line activity to print the output into the console. Let's print first the status code. Then another activity to print the result. We can run the code now. As you can see, we have first the status code. It's also 200. And below we have the result as text, but in XML format. We can then add some calculations to read the information we need from this XML string. You can check the videos on my channel, on how to read data from XML string, or how to convert XML string to data table. Before I end this video, I will address some points about API in general. First point is API kinds. There are different kinds of APIs. The most known are public APIs and private APIs. Public APIs. These interfaces can be used by everyone. However, an authentication key is often required. A popular example of this is YouTube API. Private APIs. These are internal interfaces. They are not accessible to outsiders, and offer the greatest possibility of control for companies. The next point is API types. There are basically 4 types of APIs. Function-oriented APIs. File-oriented APIs. Object-oriented APIs. Protocol-oriented APIs. These APIs mainly use functions and their parameters for communication. They allow a program direct access to the hardware of a system. Various file system calls address individual files and file functions. These APIs enable communication with the computer's storage media so that files and folder structures can be queried, read or overwritten per request. The operating system is responsible for the distribution and compliance with access rights. These APIs work with so-called interface pointers, and are far more flexible than the other API types. These APIs are characterized by their independence from a defined operating system or specific hardware. As the name suggests, communication takes place via protocols and libraries. The last point in this video I would address is the API documentation. Creating a smooth and enjoyable experience for those implementing your APIs is essential. With just how much competition there is nowadays, and API documentation is one of the keys to success. A good API documentation is characterized by different points. The main points are as follows: authentication guide, quick start guide, endpoint definitions, code snippets, example responses. An example of good documentation is the Twitter API. One last thing. If you want to test an API request, you can use some tools where you can check if the API works correct and doesn't take long time for execution. The most known tools are Postman and CURL. We are now at the end of the video. I hope you could learn more about API in this video and take away some important points for you. I really appreciate your feedback and comments. If you like the video, please share it with your friends and colleagues. Have a nice time and wait for the next video about a new topic.